Good day, grade 12. Welcome to Technical Mathematics. Today we are going to be discussing with an analytical geometry. This is the topic that we are going to be explaining. Remember, we are about to write our final exam. So really we need to outline everything which we think it will help you for this coming final examination. So make sure that when we are practicing, we are using the previous question paper, and then we should also have the examination guideline for technical mathematics and just go through that document and then look into it, check what are they saying about analytical geometry, the things that need to be known before you can go and write your final exam. And then you should also check other topics that we are doing under technical mathematics that we're going to write about for this coming final exam. So it's very, very important that when we are revising, we also have such document in front of us, the examination guideline and the previous question papers. So just get any question paper you'll find for technical mathematics, revise with it. And then don't only rely on the textbook, because remember the way in which these people are asked questions in the exam is too different from the exercise on the textbook. So if you revise with this previous question papers, you'll get the style, you get used to the style of questioning, and then you will then understand what is needed from you. So it's very important that you should have that document, right? Now let's proceed and see what are we going to be discussing for today's lesson. Let's see under content, what are we going to have? All right, under content we have analytical geometry. Remember, this topic is part of paper 2, and then it contributes 25 plus or minus 3 marks out of 150. So it's very important and very interesting topic. You just have to understand certain things, and then if you can check, I think 90%, if not 95% of the questions, they've got the formulas which are found in formula sheet. So every question that comes under analytical geometry, you should expect to get or to go and look for that formula from the formula sheet. So it's very, very important when to use which formula, all right? And then under analytical geometry, we'll be looking at linear analytical geometry, circles analytical geometry, and ellipse, all right? But today's lesson is going to be specifically for circle analytical geometry and ellipse. But I'm going to emphasize more on circle analytical geometry because I've realized that our learners, when it comes to circle analytical geometry, they've got a challenge. So I'm going to try to help them to overcome that challenge. All right, now let's start. All right, circle geometry, circle analytical geometry. One should be able to find the equation of a circle of a semicircle in the form of x squared plus y squared equals to r squared. And then we have the determine the equation of a tangent to a given circle where the gradient of a point is given. All right, these are the things that we need to look into it under circle. Now let's see if we can get a question to address everything under circle analytical geometry. All right, let's first deal with these questions and see if we can be able to understand what is needed from us. if a question comes and say, given the equation of a circle, which is x squared plus y squared equals to 100, determine the radius of the circle. That is the first question. Now let's see on how do we determine the radius of that circle if the equation is given. Now remember this 100 is r squared, right? Remember the standard equation for the circle is x squared plus y squared equals to r squared. Now in the case of r squared, we can see that we are having 100, meaning r squared equals to 100, right? Now for us to get the radius, then we need to get rid of this exponent 2 and then just put square root both sides, and then we have our radius as 10 units. So that is the value of radius. Number 2, determine the equation of a circle with the center at the origin and square root of 5 as a radius. Meaning, in this case, we are having a radius, then we can be able to determine what the equation of that circle. Let's see on how do we determine that. Since we've got the value of r, which is square root of 5, we can now see the way you see r, you just substitute with square root of 5. Then you square it, then our equation is x squared plus y squared equals to 5, right? So that is the equation of a circle. So there are two ways in which you can be able to determine the equation of a circle. You must be first given a radius. Then if you are given a radius, it's possible to determine the equation of a circle. And then if you are given what? If you are given any point on the circumference of that circle, you can be able to determine the equation of a circle, right? But I'm not going to explain on how you can do that, but we are hopefully we're going to have that question whereby you are having a point on the circumference and you are asked to determine the equation of that circle. All right, number 3, negative 5 is 2 lies on the circumference, lies on the circle with the center at the origin. Determine the equation of a circle. You see, that is the question that I just spoke about, where you are having a point on the circumference of a circle and then you are asked to determine the equation of a circle. Let's determine. And then that point is for x and y. You can see for x is negative 5, y is positive 2. Then now you can just square both values, and then you've got 25 plus 4, which is 29. The square root r squared equals to 29. So once you reached this stage whereby you have just determined the value of r squared, there's no need for you to determine the value of radius. You can just stop there and say the equation of that particular circle is x squared plus y squared equals to 29. All right. The diagram below is a circle with a center at the origin and passing through A, which is negative 2 is to negative 4, and B. Line a segment, which is AB, is the diameter of a circle, and BC is the tangent to a circle. Determine the coordinate of B. All right, let's first determine the coordinate of B. The coordinate of B is going to be positive 2 is to negative positive 4, because if you can look at this line, right, the coordinate of this point, which is point A, is negative 2 is to negative 4, right, and we know the distance from this point and this one is equal. The distance from this is equal, all right. And even if you can now do this, you can see it's positive 4, and then you can see it's positive what? It's positive 2. So that is the coordinate of that B, which is 2 is to 4. All right, and then number 2, let's determine what the gradient of the line. Let's determine the gradient of line AB. And then what is the value of YA? You can see it's negative 4, and then B is positive 4, then it's negative 4 there. XA is negative 2, and we have negative 8 over negative 4, which is equals to 2. That is the gradient of AB. The third question, determine the equation of a tangent BC, meaning we're in need of this tangent BC. But since, let's see, determine the gradient of the tangent. We first have to determine the gradient of the tangent, because for us to be able to calculate the equation of that particular tangent, because it's a straight line, we need two things, which is the gradient and the point. We can see that we have already having a point B, but the only thing which is left is the gradient. Now, how do we determine the gradient? Now, since a line AB is perpendicular to BC, we know that the gradient of AB multiplied by the gradient of the tangent is equals to -1. But remember, we've determined the gradient of AB, which is equals to 2, then multiply by the gradient of the tangent equals to -1. Then we just divide both sides with 2, and then the gradient of the tangent now is equals to -1/3. Now, since we've got the gradient, we write the standard equation. You then take that point of B, not A, because we are looking for the gradient. I mean, the equation of line BC. Then you substitute the point together with the gradient of the tangent. Then you just open the bracket, and the answer is going to give us y equals to -1/2x plus 5. All right? So that's how you should answer that question. In the figure below, the original set of circle A and B are point on the circle. AB is a diameter of a circle and BC is a tangent to a circle at point B. C is the point, it's a point K is to 1, all right? Determine the coordinate of a circle with a center O. Let's first determine this equation of that circle. Then remember, we've got a point on the circumference. That point is point B, which is 4 is to -3. And that is for x and y. You can see that we have just substituted them on this. Then we're having 4 squared is 16, -3 is squared is 9. Then you add them together, it gives us 25. Then the equation of this circle is x squared plus y squared equals to 25. All right. Number 2, show that the length of AB is 10. Show that the length of AB is 10. Now, first we need to determine the coordinate of A, and then now, what are the coordinate of A? Now, this is going to be the reflection. It's a reflecting point, this point and this one, just reflecting, because the distance is equal in every action, in every angle. I mean, in every angle, the distance is equal, all right? Meaning from here to here, from this point to this point is equals from this point to this point, right? From up there to this point is equals from this point to that point. You understand? Now, so what is going to happen every time we just take, okay, we can all see that the value of x on this point B is 4. But now, if the value of A for x is supposed to be 4, we also have to look on the quadrant. You can see that x is negative in this quadrant, hence the coordinate of x is -4, and then of y is +3. So we now having the point A and B, you can be able to calculate the distance. We just write the formula, substitute, and the square root of 100, which is 10. Then we just show that the length of AB is 10 units. The third question, calculate the gradient of line AB. Let's determine the gradient. That is the formula for the gradient AB. Then what is the value of YA, which is 3 minus formula minus the formula and minus 3, which is +3. Then it's 3 plus 3 divided by -4, which is 6/-8. And then when you simplify it, it's going to give us -3/4. We are still having the same scenario, as you can see, with the same circle. Now we've got the new questions on that. Determine the equation of the tangent BC. The equation of the tangent BC. We first remember what we need: the gradient and the point. And then we can see point B is fine. We are fine in terms of the point. We are having point B, which is 4 is to negative 3. So we are only left with what? With the gradient. Now let's see on how do we determine the gradient. But we all know that the gradient of line AB is multiplied by the gradient of BC equals to -1, because both lines, they are perpendicular to each other. All right. Then we have determined earlier on, we have determined the gradient of line AB, which is -3/4, multiplied by the gradient of BC. You can just divide both sides with -3/4. That will give me 4/3. So we have determined the gradient of BC. We can now be able to determine what the equation. You then substitute, and then from there you open your bracket with this 4/3. Then it's going to give us 4/3x minus 16/3. And then this positive 3, you transpose to this side, so it gives us -3. Then you add them together, you give us y equals to 4/3x minus 25/3. So this, what is this? That is the equation of this, the equation of a tangent I made, the equation of a tangent BC. The last question says, hence determine the value of k. Now, if you can look, where is k? K is the point of C, and that C is on this line of the tangent. It is on the line of tangent. Then now we can be able to determine. We can be able to determine that value of k. Let's see on how do we determine that. We first take the equation of that line. Then k is x. Then where you see x, you just put k, and then y is 1, and then from there you multiply. You can multiply with each term with the denominator of 3, so that we can just get rid of these fractions. Then we can see we're having everything fine. We then transpose that -25, that side is going to give us 28. Then we can divide with 4, then it's going to give us k as equals to 7. The diagram below is a circle with a center at origin and passing through B, which is 3 is to -4. Determine All right, now let's answer the following questions. Determine the equation of the circle. Remember, I will always emphasize the issue of determining the equation of a circle. It's either you're having the radius or a point on the circumference. Then this one is having a point. You just substitute the point, and then 3 squared is 9, -4x squared. -4 squared is 16 equals to r squared. You add them together, they give us r squared equals to 25. Then the equation of this circle is x squared plus y squared equals to 25. Hence, determine the equation of a tangent to a circle at point 3 is to -4. Meaning there is a line which we say the tangent is passing through this point. All right. We know that it's always perpendicular to this radius here. So now let's see on how get the gradient. Meaning we're going to say the gradient of the radius multiplied by the gradient of a tangent equals to -1. Then let's first determine the gradient of the radius. Why? Because we've got the coordinate of this point, which is O, and then B, and then we can be able to determine the gradient. Then our gradient is of the tangent. Then after simplifying there, it's going to give us 3/4. We then can be able to determine the equation. We write the standard equation for the straight line. We then substitute the values. Then we're going to open your bracket with 3/4, and that's going to give us 3/4x minus 9/4 minus 4, and then the answer is y equals to 3 over 4x minus 25 over 4. All right? Below is a circle with a center at origin and a straight line with equation x squared plus y squared equals to 10. And f of x equals to 2x plus 1 respectively. They intersect at A and B. All right, let's see. Determine the coordinate of A and B. And let's see on how do we determine the coordinate of this point A and point B. Point A point A and point B are points of intersection. To determine the point of intersection, we have to equate the two equations, all right? The equation of a circle together with the equation of what? Of a straight line, all right? Now let's see on how do we do that. Now, we can all see that a straight line, remember this is same as y, f of x equals the same as y equals to what? Equals to y equals to 2x plus 1, right? Meaning where we see y in this equation of a circle, we then substitute with this 2x plus 1. As you can see, that's what we did in the place of y. Then from there, you open the bracket, then it's going to give us this. Let me just remove this pen here. All right, x squared plus 4x squared plus 4x plus 1 equals to 10. Then you add the like terms, you transpose that 10 to the left hand side. Then now you're having 5x squared plus 4x minus 9 equals to 5. So that is in the standard form now. We can now factorize. These are the factors. Then from there you solve the value of x. So the first value of x is x equals to negative 9 over 5 or x equals to 1. All right. But according to the quadrant, you can see which x belongs to which point there. And then negative 9 over 5, we can see it's that point A, because we know that in that quadrant, x is negative. And then B is positive 1. Then now we'll have to determine the y corresponding values so that we can have what? The coordinate of A, the coordinate of B. All right. And then we first take the first value of what? X, then we substitute to one of this equation. But I always advise learners they should now use this one because already y is the subject. We just substitute the value of x there. And then the value of y is going to be negative 13 over 5 when you substitute negative 9 over 5. And then when you substitute x as 1 and then y equals to 3. So the coordinate of A is negative 9 over 5 is to negative 13 over 5. While the coordinate of B is 1 is to 3. So that's how you should determine the coordinates of the two graphs. You can also apply this one on what functions. We have such questions, so make sure that we also will have two graphs. Maybe for instance, you can have a parabola with a straight line, and then where they meet, they can ask the coordinate of that point. So on how do we start? You first equate the two equations, then you solve for x, and you then want y values. In the diagram below, O 0 to 0 is the center of a circle with the equation x squared plus y squared equals to 5. The straight line KL is with equation y equals to negative 2x plus 5 equals to 0. It is tangent to a circle at point L, which is t is to negative 1. LO is the producible to M, and then K is the y-intercept of straight line MK, and determine the numerical value of t, meaning we are in need of this t. But now, how do we determine that t? Then you take the equation of that line, which is y equals to negative 2x plus 5. You then substitute the values. our value of y is -1. You can see value of k, x is t. Then you substitute that t. Then you transpose. You divide. Then on the value of t is 2. You can also utilize or use the equation of this circle. Then you just substitute the values, and then you can now work on it. All right. The coordinate of k, let's determine the coordinate of k. Now we can all see that the k is what is y-intercept, and then we all know that in that y-intercept x is 0, hence you see 0 there. All right. Then from there you say -2 times 0 is 0, and then that plus a +5, then transpose continuous -5. So the coordinate of k is supposed to be 0 is to -5, because that the question is very clear and say coordinate of k. Another question, the equation of a straight line that is parallel to KL and passing through M. There is a line passing through this point M and is parallel to this line KL. Now determine the equation of that line. Then first we need the gradient and the point. The point we can use point M, but what about the gradient? And the gradient, let's see, is equals to 2. All right, the gradient of a line is also 2 because it's parallel to LK, meaning if you're having two lines which are parallel to each other, you know they're equal in terms of the gradient. Then we're having a gradient as equals to 2 and the point M. Then now we can just start the standard equation. You then substitute the values. Then we're going to open a bracket with that 2, and then 2 times x is 2x, 2 times 3 is 6. And then you then transpose this -3 over 2, that side is going to give us +3 over 2. You add them together, they give us y equals to 2x plus 15 over 2. In the figure below, O is the center of a circle. P and Q are points on the circumference of a circle. POQ is a straight line. The point R lies on the tangent to a circle at Q. Determine the equation of a circle. Let's determine the equation of a circle. We've got a point on the circumference, which is 12:5. Then say x is 12, y is 5, then 12 squared is 144, 5 squared is 25, and then r squared will give us 169. Then that is the equation. The equation is x squared plus y squared equals to 160. It gives us 169. So that is the equation of this circle. Now determine the tangent, the equation of a tangent RQ in the form of that. Right? We need to have the gradient and the point first, but the point is fine. We can now use the point Q, which is 12:5. What about the gradient? We first determine the gradient of OP, or OQ, I mean. OQ would give us 5/12. But because we know that OQ is perpendicular to QR, then when you multiply the gradient of RQ multiplied by the gradient of OQ equals to -1. And then remember, we have just determined this gradient, which is 5/12. And then just divide with 5/12. Then it gives us the gradient of QR as -12/5. We are having the point, we are having a gradient. We can now write the standard equation. You then substitute the values. Then you open the bracket and then you add the like terms. Then it's going to give us y equals to -12 -12/5 x plus 169/5. All right, that is the equation. Right. In the diagram below, O is the center of a circle and F its point on the circumference. FH is the diameter of a circle and G is a tangent to a circle at H. Determine the length of the radius of a circle. The length of radius of a circle. And then now from there, we just substitute the values. And then it's going to give us 100 plus 16, which is 116 equals to R squared. Then you put square both sides equals to 2 square root of 29. The question is very clear that say determine the length of the radius, not the equation of the circle, right? Hence we have to solve R and get rid of that exponent 2. The gradient of OH, let us determine the gradient. We've got that point H, which is negative 10 and 4 is supposed to be, it was not supposed to be negative 10 there. It's negative 10. O is 0 and then Y is negative 4. X positive 4. So this is supposed to be positive and then this is supposed to be negative. All right. And then negative is 5. The gradient is still 5. Even though the signs were not the same, but everything is still 5. Okay. Now we are done with the circle and analytical geometry. We are now focusing on the last part, which is the ellipse. And then, my dear learners, there's something that we need to know under ellipse. Every question that will come under ellipse, you must expect to plot the ellipse graph. Always we're going to be plotting the ellipse. So you must be able to do that. The plotting of the graph, write the equation of ellipse in a standard form. You can see this one. So the plotting is the number one. Now the ellipse can come in the different forms. It can come with this form, which is you can see it's horizontal, and it can also come in this manner, which is vertical. So now we should know when the ellipse graph is going to be vertical, when it's going to be horizontal. That is very important. But now let's have one example and see on how can we determine that. Let's see. The sketch the graph defined by this x squared over 9 plus y squared over 16 equals to 1. Clearly show all the intercept with the axis. All right. You can see that, but we'll come to this one. Let me just deal with the solution. When the bigger number is under x, the ellipse is horizontal. Now let's come here. Is 9 or 16 the bigger number? The bigger number is under what? Y, which is 16. Then when the bigger number is y, it is vertical. This is the vertical ellipse, as the bigger number is under y. We can all see that the bigger number is under y, which is 16, right? Then it's going to be vertical, meaning it must be in this manner, all right? And then we first write the equation of that so that the denominator are shown as squares, and we can identify the value of a and b easily. Because remember the standard equation for ellipse is what? X squared over 8 squared, right? But now we're having 9. We don't have a squared. For you to be able to get the value of a, then we know that this is going to give us 3 to the power 2, which is give us 9, meaning the value of a is 3. And then the same with 16, we have x squared over b squared. And then 16 we know is 4 to the power of 2, it equals 16. And the value of b is 2. Then after having a and b as values, then the 4 points we need to plot in order to sketch the ellipse are the coordinate of the vertices are. Now let's come here and check what is the vertices. We agreed that this circle is going to be what? Vertical, right? Then the vertices are comes here in this one, which is negative, positive 2 and negative 2. And then we have the coordinate of the core vertices are what core means this point there and then this point, meaning there we are going to have -3 and then there we have positive what? +3. Okay, and then after having this, you then have to take your graph paper and draw the ellipse. Then this is the solution. This is our ellipse. We can see -3, +3, +4, -4. So that is the ellipse. So you will always be asked to plot the ellipse function, right? Put in a standard form, right? The equation is standard form of this. Now look at what we are having. 4x² plus 16x 16y squared equals to 64. All right, then remember it must have equals to 0. It must be equals to 0. Let's see the solution on how do we do that. First, we are going to be dividing 64. Then we divide 64 there, 64, 64. All right, so that we can have equals to 1. Then after having that, we say 4 divided by 6. 4 it gives us 1 over 16. Then that 1 is going to be x² over 16. Then 16 divided by 64 equals 1 over 4. Then it's going to be y squared equals y squared over 4 equals to 1. Then we can now clearly see what is the value of A, which is 4, the value of B, which is, all right. That is that. Well, I think we are done with this one, and then let's proceed. All right. Thank you very much for being with me on this lesson. I hope everything that we have discussed on this lesson is going to help you to understand the circle and geometry. So let's hope that we are going to push until we first write the paper of technical mathematics and the second paper. But now let me just leave you with this word that says, study like there's no tomorrow, because if you keep putting off your studies for tomorrow, you'll probably be late. All right. Thank you very much. Have a nice day. Thank you. See you tomorrow.